Okay, so we're gonna go ahead and continue looking at example number 4. Okay, so what I've done on example number 4 is I went ahead and I went to Desmos. I went to up here to add item, and I added a table. Okay, so now I have my table here. I've already gone ahead and entered all my data. It was a lot of data to enter. Okay, but I have all those data values. Now, after I entered them, I'm not seeing anything here. Okay, so what I'm going to do is I'm going to scroll to the bottom of my data, click on this little zoom fit magnifying glass down here on the bottom left, okay, down here, and I'm going to go ahead and click that, and what it should do is it should bring up all my data here. Okay, so this is a scatter plot that I should be sketching. I should have something that looks kind of like this. Now remember, when I put in this data, we decided that the powerboat registrations was the explanatory variable. So even though the table they gave me, it was the second set of values, it really is the first set of values. It is your X values, okay? So all of your X values needed to be your powerboat registrations over there, okay? And then all of your Y values over here were going to be your number of manatees killed, okay? So make sure that you didn't mix those up when you were doing this scatter plot. And so we can see there is a positive association, right? So as the number of powerboats is increasing registered, the number of manatee deaths is going up, and it does appear to be linear, okay? So let's go ahead and let's take a look at answering some of the questions now. So one of the questions says, make a scatter plot. So we did that, okay? I'm just gonna write here C Desmos. Okay, you need to attach your Desmos graph if you use Desmos, or you need to do a hand sketch. Okay, describe the association that you see. So I would say it's moderately strong. And it's positive. It appears to be linear. Okay, I don't see a curve or anything like that there. Okay, so next it says find the correlation between boat registrations and manatee deaths. Okay, so we're going to go back to Desmos to do that. Okay, so we're going to go back to Desmos. In Desmos, we're going to go ahead and we're going to enter on the next line our y1 tilde m x1 plus b. Okay, and then it goes ahead and it's giving me a line of best fit. Now, I can take a look at some of these numbers here, and it's giving me my correlation coefficient, which is this R value, which is 0.9511. So my R value is 0.9511. Okay, now I said it was moderately strong, but my correlation coefficient is actually telling me it's very strong. So maybe I'll cross off this moderately after taking a look at the actual correlation coefficient and say this is a strong positive and appears linear, okay, after looking at that correlation coefficient. Okay, does your analysis prove that powerboats are killing manatees? Okay, well, we can't necessarily prove that powerboats are killing manatees, okay, but it's very strongly suggesting that as there are more powerboats registered, that manatee deaths are going up. So we don't necessarily know for sure if powerboats are killing manatees, right? Maybe by powerboat registration going up, it's like polluting the water more, and then that's what's killing manatees. Or maybe it's, manatees are having injuries from powerboats and then they're dying, but we can't actually prove it, right? It's not saying that it's causing it, but it's looking that way, right? So we can say we can't actually prove. I mean, it could be a coincidence, right? Maybe more manatees are dying because there's a manatee disease going on that's been progressing over the years. Like, we don't actually know that powerboats are killing manatees, okay? But there's a very, very strong association there. So it seems very likely that increased powerboat registration is contributing to manatee death. Okay, so like I said, we don't know for 100% sure that this is the reason why manatees are dying. You know, there could be something else going on. Okay, however, there's a very strong positive association. So although, remember, correlation doesn't mean causation, but it can tell us that there's kind of maybe something going on there. Okay, all right. Okay, let's go on to number 5. Okay, number 5 says, here are the fat and calorie contents of several brands of burgers. Analyze the association between fat and calorie content. Okay, so I'm going to go back here to Desmos. I'm actually going to save my manatee graph. Okay, before I open a new graph. Okay, so I'm going to go ahead and I'm going to open a brand new graph here. Okay, and I'm going to use these numbers that they gave me for fat and calorie content. So let's go ahead and add in a table of values. Okay, my fat numbers are 19, 31, 34, 35, 39, 39, and 43. Okay, and then here are my calorie numbers: 410, 580, 590, 570, 640, 680, and 660. Okay, so now that I've got those, let's go to my little Zoom Fit over here. Okay, I want to make sure I click on that. And so I'm going to click on the Zoom Fit button. Now I can see my data values there. Okay, so when I'm looking at these, it does seem to be positive. Okay, I would say moderately strong. Positive association. Okay, and then let's go ahead and just, to kind of give us an idea, we can go ahead and do our y1 tilde m x1 plus b into our second line. And it's giving me a pretty good correlation coefficient there. My R value is 0.9606. So that's pretty strong, okay, when I'm looking at my line of best fit. All right, so there does seem to be some kind of association here that it's looking like as your fat increases, so do your number of calories, right? So we're kind of looking at that, you know, as fat goes up, calories goes up as well, right? So the x-axis, this is your fat. Okay, the y-axis over here, this is your calories. So as we're increasing in fat, we're also increasing in calories. So it does seem to be an association there. So I can maybe write about that. So I could write as the number of fat grams increases, so do the number of calories. I'm just going to abbreviate here because I'm running out of room. All right. Okay, so that's the wrap up on number 5. Okay, let's go to number 6. Okay, so here's number 6. Okay, number 6 says, perhaps fans are just more interested in teams that win. The displays and tables are based on American League teams for the 2013 season. Okay, we wonder whether the teams that win are those with higher attendance. Okay, do the winning teams generally enjoy great attendance at their home games? Describe the association. All right, so they gave us some data here. They also, it looks like they gave us a graph for us, so we don't need to go into Desmos and graph that. Okay, and so what we're looking at here along the x-axis is number of wins. Okay, we are looking at along the y-axis home attendance. Okay, so it says, do the winning teams generally enjoy great attendance at their home games? Describe the association. Okay, so when we're looking at their wins, okay, when we're looking at more wins, it's looking like it kind of varies, right? You have some low attendance, you also have some high attendance over here. When they have not very many wins, there's no high attendance at all, okay? I can see that, you know, kind of right over here, there's no high attendance. So you could kind of say that this is generally positive, but it's a little bit vague, right? But we could say, yeah, in general, it seems like if they're not winning at all, the attendance is really low. And it's more likely for them to have some higher attendance if they're winning more, right? So we would say, it says describe the association, so I'd say it's positive. Okay. As teams win more, attendance seems to be higher. Okay. Is attendance more strongly associated with winning or scoring runs? Okay, so let's look at over here. Okay. When we're looking at these correlations, okay, we've got over here, here's our attendance, right? Here's our runs, and we've got some runs over here, and here's wins. Okay, so when we're looking at the correlation between runs versus attendance, so runs versus attendance, our correlation is right here. Okay, so our correlation for runs versus attendance is 0.384. Okay, now when we're looking at our correlation between wins versus attendance, so here's wins versus attendance, that would be here. Okay, wins versus attendance is 0.254. So neither of them are a very strong correlation, but when we're looking, the correlation for runs and attendance does seem to be higher. So what I would say is, it says, is attendance more strongly associated with winning or with runs? I would say it's more correlated with runs. Because remember when we looked at the correlation here between attendance and wins, it was positive, but it was also very weak, right? And we can see that from the numbers they gave us here, looking at wins and attendance. That correlation is very weak. Now, the correlation between runs and attendance here is also weak, but it's not as weak. So we would go with runs for part B. Okay. Now, the last part says, How strongly is scoring more runs associated with winning more games? Okay, so let's look at the association between wins and runs, so which is right here. Okay, and so when we look at wins and runs, we've got a 0.793 correlation. So this is a fairly, it indicates a strong association. So it's a 0.793 correlation from the chart, indicates a strong association. Okay, so this would be telling us that, you know, as runs increase, so does the likelihood of wins, right? So as the number of runs increase, the number of wins increase. Okay, so it does indicate a strong association.